I'm Miss Roberts, and I'm a 4th grade teacher at Amherst Elementary School. Go Sharks! I'm also a math demonstration classroom for Knox County Schools. In the last video for KCS at Home, you were given a challenge. Let's review it here. If 5 kids meet each other and each shakes hands only once with each of the others, how many handshakes will there have been? Okay, drum roll for the answer, please. And the answer is 15 handshakes. Great job. Today, I'm here to discuss Unit 3, Multiply and Divide Whole Numbers. This is a great review as this is the main core of what you learn in 4th grade, and it applies to so many things throughout the year. So we'll start out with multiplication vocabulary. So let's talk about factors. You have heard it in our previous videos, but it's important to make sure you understand what it actually means. Factors are 2 numbers you multiply together to get a product. A product is the answer to a multiplication problem. In the equation below, can you identify the factors in the product? If you said 2 times 2 are the factors and 4 is the product, you're correct. We're also going to discuss partial products, which is a strategy used to multiply multi-digit numbers. To multiply with 3-digit and 4-digit numbers, you need to understand how to multiply by multiples of 10, 100, and 1,000. This will be helpful when answering the questions in the first and second task. So, let's look at the chart below. Starting in the expressions column. Expressions are different from equations because equations have the equal sign and a product. So we're going to look at the basic fact of 4 times 3. If the 3 is sitting in the 1 spot, it has the value of 3 ones. So the product of 12 would actually show 12 1 cubes if you're dealing with place value blocks. Now if 3 was sitting in the 10 spot, it would represent 3 tens, a value of 30. You could use the place value blocks to show 12 10 rods, or you could find the basic fact of 4 times 3 is 12 and add a 0 to get the product of 120. If the 3 is sitting in the 100 spot, it represents 3 hundreds or 300 flats in the place value blocks. You could also answer this mentally by finding the basic fact of 4 times 3, which is 12, adding the 2 zeros to get the product of 1,200. And last, if the 3 is sitting in the 1,000 spot, it represents 3,000, or 3 thousands cubes if you're dealing with place value blocks. So you can again find 4 times 3, which is 12, and add the 3 zeros to get the product of 12,000. So what this is important to remember is to always find the basic fact, just as we did here with 4 times 3, no matter what place value it's in. And then we would add the zeros that we have in the factors to the final product. And this is helpful the bigger the numbers that you start to multiply, because you can do them mentally if you know how to find the basic fact when multiplying with tens, hundreds, and thousands. Now, let's review and practice some of our math strategies we've learned using this problem. Ezekiel has 3 building sets. Each set includes 1,125 pieces. How many pieces are in all 3 sets? Now I'm going to show you the strategy of the area model with 3 times 1,125. And here I've created my area model with 4 boxes because when you expand 1,125, there will be 4 digits and 4 place values. So I will set my 3 up on the side with my multiplication symbol, and now I will create 1,125 in expanded form. So we'll start from left to right. I have a 1 in the 1,000 spot, plus a 1 in the 100 spot, plus 20, plus 5. Now, when we are separating these place values, these bars here, I tell my students they equal the plus signs as well, so we add the plus sign so that we don't forget that's what we're doing. So now we will distribute the 3 to every place value. starting from left to right. 3 times 1,000 is 3,000. Next we'll say 3 times 100 is 300. Then we'll say 3 times 20 is 60. And 3 times 5 is 15. These are the partial products, and now you will add them up. And I tell my students to line them up based on place value, starting with greatest to least. So we will add 3,000, 300, 60, and 15. In the ones column, we have a total of 5. In the tens column, 7. In the hundreds column, 3, comma. In the thousands column, 3. So you have a final product of 3,375. So now I'm going to show you the partial product strategy with the same problem of 3 times 1,125. You'll distribute the 3 to every place value. So we're going to start with the ones place. So 3 times 5 is 15. Now when you're writing your partial products, you'll want to line them up in their place values accordingly. Next, you'll distribute your 3 to the tens place, which is 20. Find your basic fact of 3 times 2, which is 6, plus a 0 to give you 60. Distribute the 3 to the hundred spot, which is 100. Find the basic fact of 3 times 1, which is 3, and add the 2 zeros, which is 300. I also like to continue to write the zeros first, then my final answer to keep those place values in order. And last, distribute the 3 to the thousand spot, which is 1,000. So 3 times 1 is 3, plus 3 zeros. Now these are the partial products, and you will want to add them up to get the final product. So in the ones column, you have the answer 5. In the tens column, you have 7. In the hundreds column, you have 3. In the thousands column, you have a 3. So your final product is 3,375. So now we're going to continue to practice multiplication, but this time with a 2-digit by 2-digit number. And the following problem. Folding chairs are set up in a school auditorium for a play. There are 16 rows of chairs, each with 28 chairs. How many folding chairs are there? For this problem, 16 times 28, I'm going to continue demonstrating the area model. You may use the partial product strategy if you'd like. Most students tend to use this method as it becomes their favorite the more they work it out. So, first thing I'm going to do is expand 16 by 10 plus 6. And it does not matter if you put it on the top or down the left side as you're doing 2-digit times 2-digit. Next, I will expand 28 into 20 plus 8. And we will distribute these digits to each place value using multiplication. So I'm going to start in my first box of 20 times 10. And you find your basic fact of 2 times 1 is 2, and then you add the 2 zeros to give you a partial product of 200. Then you'll distribute the 20 times the 6, basic fact of 2 times 6, which is 12, and then you add the 0. Moving down to the next box, 8 times 10 is 80, and then 8 times 6 is 48. Now these are the partial products, and you will need to add these up to get the final product. I always tell my students to line them up evenly in their place values from greatest to least. So first we're going to do 200, 120, 80, and 48. In the ones column, you have the answer of 8. In the second column, you have, I like to make friendly numbers, so 8 and 2 is 10, plus 4 is 14. You'll regroup the 1 to the hundred spot, and then 2 plus 2 is 4. So you have a final product of 448. So remember, when you're working on your math task that's provided for you in your packet, you can choose to do any strategy. Choose the one that you enjoy best to help you multiply, especially in tasks 1 and 2. So now let's discuss division. I've given you a poster here so that you can reference where these vocabulary words actually match within the division equations. So let's discuss divisor. Divisor is the number that you are dividing another number by. The dividend is the number that is divided by the divisor. A quotient is the answer to a division problem. And the remainder in division is the amount left over that cannot be divided evenly by the divisor. This poster also shows that you can write division equations 2 different ways, and it's important to know exactly how to write them because it's important to remember where you put your dividend and your divisor in both equations. Now I'm going to show you a division strategy that will help you answer the task number 3 and 4 in your packet. So now I'm going to demonstrate the partial quotients method with the problem 2,125 divided by 4. And I've color-coded it so that you can see how to set it up in this problem. So we're going to start out by looking at the first place value in the dividend, which is the thousands place. That 2 represents 2,000. So we'll divide 2,000 by 4. And I always find my basic fact of 20 divided by 4, or 5 times 4 gives me 20, and then I add on those 2 zeros. So I have 500. That's a partial quotient, and I need to line it up within the place values on top of the dividend. I will then multiply 500 times 4. I always bring my extra zeros from the partial quotients down first, because often if my product of my basic fact ends in a 0, sometimes that gets confusing of how many to actually add. For example, 5 times 4 is 20. So you need 3 zeros instead of 2. Now we'll subtract. 5 minus 0 is 5, 2 minus 0 is 2, and 1 minus 0 is 1. Now we start the process all over again. So we'll look at the hundreds place value, and it has a value of 100 divided by 4. And I always like to think of 100 as a dollar bill, and when you divide it equally by 4 parts, you get 4 quarters, and those 4 quarters have a value of 25. So then I'll add 25 above my dividend, and then I'll multiply 25 times 4, which is 100. And then I'll subtract. 5 minus 0 is 5, 2 minus 0 is 2. And now some students will see the basic fact already, 25 divided by 4. However, we're going to continue the same method of looking at the place values the way we've been doing it so far. So I'll look at the 2. It has a value of 20 divided by 4. And I know 4 goes into 20 5 times equally. I'll add my 5 here above the dividend. 5 times 4 is 20. And when you subtract that, you have an answer of 5. A lot of students will then say, oh, I'm done, and I have a remainder of 5. But you need to remember, your remainder cannot be greater than your divisor. Your remainder needs to be lower than that. Because if it's a 4 or higher, that means 4 can go into it again. For example, 5 divided by 4 can still have an answer of 1. So I add that above my dividend. And 1 times 4 is 4. Now when we subtract, 5 minus 4 equals 1. Now you can say that 1 is your remainder because it is less than the divisor of 4. Now, these partial quotients must be added to get your final quotient for this problem. And we will line it up based on place values, greatest to least. So when I look at my ones column, I have 5 plus 5 plus 1 is 11, and I regroup my 1 to the tens. 2 plus 1 is 3, and 5 plus 0 is 5. But I cannot forget my remainder of 1. So my final quotient is 531, remainder of 1. So now you have your packet. The packet that has been provided for you gives you 4 different tasks in which you will need to multiply and divide to solve. Remember, Multiplication and division are inverse properties of each other, and you can do them simultaneously to help you solve any of these problems. These tasks do not have just one right answer. Depending on how you multiply or divide can give you multiple answers in the long run. So don't compare your answers to your friends or to the packet TE that's listed online. There are more than just one correct answer. So let's look over quickly task 1 to set you up for success. It's about a worm farm. In this one it says Bo likes to recycle. He wants to start a worm farm where he can recycle kitchen scraps from people in his neighborhood, and he gathers this information. In the white box is listed all his data. 2,000 worms can eat about 1 pound of food in one day. I can collect 50 to 65 pounds of scraps each week. Now let's look at the prices for each of the red worms. 1,050 worms cost $25. 2,950 worms cost $72. So this is where it's nice to understand how to multiply and divide those multi-digit numbers as you're dealing with numbers that go up to 4 digits. Now, the problem asks you, show how to find the number of worms Bo needs for this amount of scraps. Tell how many and what size packages Bo can buy to get this many worms. Give the total cost of buying the worms. So when you're looking at this, the first thing to do is to think about, what information do I have, or what's given to me? So I'll let you think about that for a minute. You can circle it or highlight it if you have that available. If you thought about how fast worms can eat, how much scrap food Bo can collect, and cost of worms, you're correct. Also, think about how you might solve this problem. If you said you can multiply or divide, both strategies will work. So, look at the example solution provided for you. They show you how they thought through the problem to answer it and multiplied. Now it's time for you to think of another way to solve this problem. So, decide how many pounds of scraps you would use. Estimate means rounding to find the total number of pounds of scraps in a week. Find the number of worms, number of packages, and finally the cost. Remember, it's okay to have extra worms. Use a piece of notebook paper to write down your answer. Hopefully that sets you up for success on finding a solution for task 1. So now let's look at task 2, recycle it. The problem here is because of his composting work, Bo decided to start other recycling projects. He wants to promote recycling in his neighborhood. This is the slogan he will use to start a recycling campaign. Everyone can recycle at least 30 pounds of waste in 3 months. Bo weighs different items that can be recycled. Here are some of the items he found that weigh about 1 pound. So you have cardboard boxes, you have sheets of printer paper, empty plastic water bottles, and empty aluminum cans. It asks you to help Bo write a report to show ways people can recycle 30 pounds of waste in 3 months. So think about, how could you collect 30 pounds of waste in 3 months? How will breaking 30 apart help you solve the problem? So remember how we created those area models and expanded form of numbers. Use the problem-solving checklist to help you solve on your own sheet of paper. Plus, it helps you think if you ever get stuck. Now, you have additional tasks that I'm showing you here. You have rainwater recycling and recycled robots. You'll read through these and continue to solve these the same way you've done previously. Now, it's okay if you have to multiply and divide, add and subtract on these problems. In all these review videos, you've learned all of these skills, and you've learned them throughout the school year. So it's okay if you have to use multi-operations in order to help you solve this. Always remember there is more than one right answer. Now, I have a challenge for you. And the challenge is, can you make the number 24 using all of these numbers? 9, 4, 1, and 2. However, you can only use each number once, but you can use any operation, meaning addition, subtraction, multiplication, and division. Do you accept the challenge? May the force be with you.